in the previous video, and we said that when a number is written as a to power n, then a is called the base and n is called the index, and in plural this is what we call indices in plural. Now, indices are therefore numbers that are written in the form of a raised to n, and we did an example of taking 5 raised to 4, we multiplied by 5 raised to 3, and we found the answer to be 5 raised to 7. Now, in this video we want to focus more on different operations on indices, and it is important to note that a number of mathematical operations can be done using indices. For instance, we've just worked on multiplication, and there are rules that we use when working on indices, and we will begin with multiplication. So multiplying indices, to multiply indices we need to follow the rule a raised to n. If we multiply by a raised to m, our answer will be a raised to n plus m. Let's do a few examples. Let's take 2 raised to 3, we multiply by 2 raised to 4. Our answer will be 2 raised to 3 plus 4, which is the same as 2 raised to 7. If we do another example, we take 3 raised to 6 multiplied by 3 raised to 8, we add 8 and 6, we get 3 raised to 14. Another example, maybe let's work with some unknown x raised to z multiply by x raised to y, we get x raised to z plus y. Another example, x raised to 2n multiply by x raised to 4n, we get x raised to 2n plus 4n gives us 6n. Another example, a to power 4 times a to power 3 is equal to a to power 7. A to power 10 times a to power 13 is equal to a to power 23. We simply add 10 plus 13 to get 23. A to power 7 times a to power -3. We will take a to power 7, we subtract 3, we just add -3. This is the same as subtracting 3, and that gives you a to power 4. So it is possible to operate on indices by multiplication if we follow the rule, which I'll remind you again here. A raised to n times a raised to m equal to a raised to n plus m. It is important to state it clearly here that you can only multiply two indices if they have the same base. Therefore, we can say that a raised to n cannot be multiplied by b raised to m to get any result, because it is not equal to a raised to n plus m, nor is it equal to b raised to n plus m. A raised to n times b raised to m remains a raised to n times b raised to m. You can't multiply these using the law of indices, the law of multiplication of indices, because they have different bases. The base for this is a and the base for this is b. So multiplication rule only works when you have similar bases. The powers don't have to be the same, but the bases have to be the same for you to multiply. Another law of indices is the one for division, whereby if we have a raised to n divided by a raised to m, what you end up with is a raised to n minus m. Now, examples: a raised to 5 divided by a raised to 2. This comes to a raised to 5 minus 2, which is equal to a raised to 3. It is important that we understand how this comes. So I am going to show you the proof of this. Let's just use the same values or the same problem we have had here, which is basically a raised to 5 divided by a raised to 2. What we end up with here is a raised to 5 over a raised to 2, because this is another way we can write a raised to 5 divided by a raised to 2. And this, when we write the numerator out in terms of a, you'll realize we have a times a up to 5 times, and the denominator will be a times a. Now look here, if you cancel this out with this and this out with this, you will be left with 3a's at the numerator, and so we can say a times a is a raised to 3, or simply a cubed, which is the same answer we have up here. The other example for dividing indices would be, if I have b raised to 40, I divide by b raised to 13, my answer would be b raised to 40 minus 13, which is basically b raised to 27. This can be done even with powers of 10. 10 raised to 31 divided by 10 raised to maybe 15. What we end up with is 10 raised to 31 minus 15, which is simply equal to 10 raised to 16. Another example: 2 raised to 40 divided by 2 raised to 31. You can pause this video and try to solve this. So the answer for this would be 2 raised to 40 minus 31, which is equal to 2 raised to 9. Another example would be 3 raised to power 13 divided by 3 raised to power 7, which becomes, simply subtract 7 from 13 and you'll get 3 raised to the result of that, which is basically 3 raised to 6. If you find any of these kind of problems, you simply use the law of indices for division, which I wrote to you as a raised to n divided by a raised to m should give you a raised to n minus m. And this is the rule. This is the same as simply saying a raised to n divided by a raised to m can be written as a raised to n over a raised to m, which is still going to give you the same answer as a raised to n minus m. Another law of indices is the reciprocal law of indices. Now this one is written as a raised to negative n is equal to 1 over a raised to n. Now this law can be proven by using an example such as a raised to 2 divided by a raised to 5 will give us a raised to 2 over a raised to 5. Now this can be written out as a times a times a, oh sorry, those are two a's, over a times a times a times a times a, 5 of them. Then cancel this with this and this with this. You are left with 1 over a cubed. Now 1 over a cubed is found by dividing a raised to power 5, a raised to power 2 divided by a raised to power 5. But as we can see, it is possible to note or notice that actually this could have been found by just taking a raised to power 2 divided by a raised to power 5, and following the previous law of indices, the law of division for indices, which is basically a raised to 2 minus 5, you'd get a raised to negative 3. You can see that this is what you get when you divide this by this. Hence, a raised to negative 3 is equal to 1 over a raised to 5. And that is the proof of this law. Let's take an example in operation. A raised to negative 4, if we multiply by a raised to negative 9, we can work it out by taking a raised to negative 4, a raised to 9 remains as the numerator, but this one goes down so that we have a raised to 4. And now we can subtract them and say a raised to 9 minus 4, which is a raised to power 5. You can basically do that in a mathematical operation and you have your answer. It is very easy if you already know the laws of indices that you're going to work with. Another law of indices is written as a raised to n raised to m, which is given as a raised to nm. So this one says that when you raise a power to a power, you multiply the powers. When you raise a power to a power, you simply multiply the power so that you get n times m, which is equal to a raised to nm. Now, the example here is if I have 2 raised to 3 raised to 2, what I get here is like saying 2 raised to 3 squared, which is 2 raised to 3 times 2 raised to 3, and that gives us 2 raised to 3 plus 3, which is simply 2 raised to 6. Another example would be 2 raised to 4 raised to a half. We multiply the powers just as I said, and so we end up with 2 raised to 2. If you multiply 4 times a half, you get 2. So 2 raised to 2. Another example, 3 raised to 6 raised to 8. That gives me 3 raised to 48. That's a big number. If we have 2 raised to 10 raised to 3, it's just to say 2 raised to 30. Another example is to say 8 raised to 6. This can be written as 8 becomes 2 raised to 3, and then we have 6 outside, which now gives us 2 raised to 18. Very easily, even in many other examples with unknown, like x raised to n raised to 3 is equal to x raised to 3n. X raised to 20 raised to 3 is x raised to 60. We simply multiply 3 times 20 to get 60. Now, another law of indices that is already well known is if we raise any number to 0, what we get is 1. It doesn't matter what number you're raising to 0. Even if it is 1000 raised to 0, you get 1. If it is 1,000,000 raised to 0, you get 1. Now, we can prove this to help us understand how that comes about. Really, if we have x raised to 5, for instance, and we are dividing by x raised to 5, what you expect is x raised to 5 minus 5, which is simply equal to x raised to 0. But if you look at it in another way, you see x raised to 5 divided by x raised to 5 can be written as x raised to 5 divided by x raised to 5. If you follow the previous methods that I've used to show the working, you will notice that this one becomes cancel this with this and you get 1 over 1. So therefore x raised to 5 divided by x raised to 5 is equal to x raised to 0, which is equal to 1. This should be the case for all numbers. If you raise a number to 0, you simply get 1. Now, another law of indices is the fractional powers. If I have x raised to 1 over n, this is the same as the nth root of x. Now, that is to say, if I have x raised to a half, that becomes the square root of x. If I have x raised to a third, it becomes the cube root of x. If I have x raised to 1 over 4, what I end up with is x, the fourth root of x, and it goes on and on and on. And so let's use a number. 8 raised to a third can be written as 2 raised to 3 raised to a third, and as I said earlier, you can open the bracket by multiplying the power, but because we want to follow this example up here, let's say this is cube root of 2 raised to 3. And what you can be sure about is that the cube root of 2 raised to 3 is